and welcome back to the channel. I'm so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment, and for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today we are going to continue our journey into polynomial functions. This is part 2, focusing on division and theorems. This lesson is suitable for SHS 1 and SHS 2 students. Now, I know that when you hear the words polynomials or theorems, you might feel a little nervous. Many students find this topic challenging because there are many steps and rules to remember. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes. So we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to perform division of polynomials using long division and synthetic division. You will learn how to state and apply the remainder theorem. You will learn how to state and apply the factor theorem. You will learn how to factorize cubic and higher order polynomial expressions. You will learn how to solve polynomial equations of degree 3 and higher. And finally, you will learn how to identify missing terms in polynomials during division. That is a lot, but we will take it one piece at a time. Let us start with section 2, Introduction to Polynomials. What is a polynomial? A polynomial is an algebraic expression consisting of variables and coefficients. It involves only the operations of addition, subtraction, multiplication, and non-negative integer exponents. This means you can have x squared, x cubed, and so on. But you cannot have negative powers or square roots of x. The general form is written as p of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 and so on down to a sub 1x plus a sub 0. Here, n is the degree of the polynomial. This is just the highest power. A sub n is the leading coefficient. This is the number in front of the highest power. A sub 0 is the constant term. This is the number without an x. Let us look at some examples. 2x plus 1. The highest power is 1, so the degree is 1. This is called linear. X squared minus 4. The highest power is 2, so the degree is 2. This is called quadratic. 3x cubed minus 2x plus 5. The highest power is 3, so the degree is 3. This is called cubic. I need to give you a very important warning. Expressions with negative powers, like x to the power of negative 2, are not polynomials. Expressions with fractional powers, like the square root of x, are not polynomials. A polynomial must have whole number powers only. Please remember this well. Now let us move to section 3. Division of polynomials. When we divide a polynomial p of x, which is called the dividend, by another polynomial d of x, which is called the divisor, we get a quotient q of x and a remainder r of x. The formula is p of x equals d of x times q of x plus r of x. There is a degree rule. The degree of the remainder must be less than the degree of the divisor. This means if you are dividing by x, The remainder is just a number. If you are dividing by x squared, the remainder can have an x term. We have two methods. Method 1 is long division. This method works for any divisor. Let us look at example 1. Divide 2x cubed plus 3x squared minus 5x plus 1 by x minus 2. Step 1. Arrange terms in descending order. This means highest power first. In this case, it is already done. Check for missing terms. We have x cubed, x squared, x, and a constant. None are missing. If one was missing, we would have to put a 0 there. Step 2. Divide the first term of the dividend by the first term of the divisor. The first term of the dividend is 2x cubed. The first term of the divisor is x. 2x cubed divided by x is 2x squared. This is the first term of the quotient. Write this on top. Step 3. Multiply the entire divisor by this result. The divisor is x minus 2. The result is 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. So we get 2x cubed minus 4x squared. Step 4. Subtract this from the dividend. We have 2x cubed plus 3x squared. Subtract 2x cubed minus 4x squared. 2x cubed minus 2x cubed is 0. 3x squared minus negative 4x squared. Remember, minus negative becomes plus. So 3 plus 4 is 7. We get 7x squared. Step 5. Bring down the next term. The next term is negative 5x. So our new current dividend is 7x squared minus 5x. Step 6. Repeat the process. Divide the first term of the new dividend by the first term of the divisor. 7x squared divided by x is 7x. This is the next term of the quotient. Multiply the divisor by 7x. 7x times x is 7x squared. 7x times negative 2 is negative 14x. So we get 7x squared minus 14x. Subtract this from the current dividend. 7x squared minus 5x minus open bracket. 7x squared minus 14x close bracket. 7x squared minus 7x squared is 0. Negative 5x minus negative 14x. Minus negative becomes plus. Negative 5 plus 14 is positive 9. So we get 9x. Bring down the next term, which is plus 1. Our new current dividend is 9x plus 1. Step 7, repeat again. Divide 9x by x. This gives 9. This is the last term of the quotient. Multiply the divisor by 9. 9 times x is 9x. 9 times negative 2 is negative 18. So we get 9x minus 18. Subtract this from the current dividend. 9x plus 1 minus open bracket, 9x minus 18. Close bracket. 9x minus 9x is 0. 1 minus negative 18. Minus negative becomes plus. 1 plus 18 is 19. We have no more terms to bring down, so 19 is the remainder. The result is quotient 2x squared plus 7x plus 9. Remainder 19. Verification, p of x op equals open bracket x minus 2 close bracket times open bracket 2x squared plus 7x plus 9 close bracket plus 19. Now let us look at method 2. This is synthetic division. It is a shortcut. But listen carefully. This method is faster, but it only works when dividing by a linear term like open bracket x minus k close bracket. You cannot use it for x squared. Let us revisit example 1. Using synthetic division, divide 2x cubed plus 3x squared minus 5x plus 1 by x minus 2. Step 1. Write down the coefficients of p of x. The coefficients are 2, 3, negative 5, and 1. Write k outside. The divisor is x minus 2, so k is 2. So we write 2 on the outside, and then 2, 3, negative 5, 1 in a row. Step 2. Bring down the first coefficient. Bring down the 2. Write it below the line. Step 3. Multiply by k and add to the next coefficient. Multiply the 2 we just brought down by the k outside, which is 2. 2 times 2 is 4. Write this 4 under the next coefficient, which is 3. Add them. 3 plus 4 is 7. Write 7 below the line. Now multiply this 7 by the k outside, which is 2. 7 times 2 is 14. Write this 14 under the next coefficient, which is negative 5. Add them. Negative 5 plus 14 is 9. Write 9 below the line. Now multiply this 9 by the k outside, which is 2. 9 times 2 is 18. Write this 18 under the last coefficient, which is 1. Add them. 1 plus 18 is 19. Write 19 below the line. The numbers below the line are 2, 7, 9, and 19. The last number is the remainder, so remainder is 19. The other numbers are the coefficients of the quotient. Since we started with x cubed, the quotient starts with x squared. So the quotient is 2x squared plus 7x plus 9. This matches our long division answer. I need to give you a warning. If a term is missing, for example, if you have x cubed plus 1, you must use a 0 placeholder. You would write the coefficients as 1, 0, 0, 1. Do not skip the zeros. Now let us move to section 4, the remainder theorem. Here is the statement. If a polynomial p of x is divided by a linear divisor open bracket x minus a close bracket, the remainder is equal to p of o. Why use it? It allows you to find the remainder without performing long division. It is a huge time saver. Let us look at example 2. Find the remainder when p of x equals x cubed minus 4x plus 2 is divided by open bracket x minus 3 close bracket. Step 1. Identify a. The divisor is x minus 3, so a equals 3. Step 2. Evaluate p of 3. This means wherever you see x in the function, replace it with 3. P of 3 equals 3 cubed minus 4 times 3 plus 2. 3 cubed is 27. 4 times 3 is 12. So we have 27 minus 12 plus 2. 27 minus 12 is 15. 15 plus 2 is 17. The answer is the remainder is 17. See how much faster that was than long division? Let us try example 3, finding unknown coefficients. When p of x equals 2x cubed plus kx squared minus 5x plus 1 is divided by open bracket x plus 1 close bracket, the remainder is 4. Find k. Step 1. Identify a. The divisor is x plus 1. This is the same as x minus negative 1. So a equals negative 1. Step 2. Set p of negative 1 equals 4. Replace x with negative 1 in the function. 2 times open bracket negative 1 close bracket cubed plus k times open bracket negative 1 close bracket squared minus 5 times negative 1 plus 1 equals 4. Let us simplify. Negative 1 cubed is negative 1. So 2 times negative 1 is negative 2. Negative 1 squared is positive 1. So k times 1 is just k. Negative 5 times negative 1 is positive 5. So we have negative 2 plus k plus 5 plus 1 equals 4. Combine the numbers. Negative 2 plus 5 is 3. 3 plus 1 is 4. So k plus 4 equals 4. Subtract 4 from both sides. K equals 0. The answer is k equals 0. This shows how useful the theorem is for finding missing numbers. Now let us move to section 5, the factor theorem. The factor theorem is a special case of the remainder theorem. Here is the statement. If P of a equals 0, then open bracket x minus a close bracket is a factor of P of x. Conversely, if open bracket x minus a close bracket is a factor, then P of a equals 0. How to use it? To check if open bracket x minus a close bracket is a factor, simply calculate P of a. If the result is 0, then it is a factor. If the result is not 0, then it is not a factor. Remember, for something to be a factor, the remainder must be 0. Let us look at example 4. Verifying a factor. Show that open bracket x plus 2, close bracket is a factor of P of x equals x cubed plus 3x squared minus 4. Step 1. Identify a. The divisor is x plus 2. This is x minus negative 2. So a equals negative 2. Step 2. Evaluate P of negative 2. Replace x with negative 2. P of negative 2 equals open bracket, negative 2, close bracket, cubed, plus 3 times open bracket, negative 2, close bracket, squared, minus 4. Negative 2 cubed is negative 8. Negative 2 squared is positive 4. 3 times 4 is 12. So we have negative 8 plus 12 minus 4. Negative 8 plus 12 is positive 4. Positive 4 minus 4 is 0. Conclusion. Since P of negative 2 equals 0, open bracket x plus 2, close bracket is a factor. This is a very standard exam question. Now let us move to section 6, factorizing polynomials, specifically cubics. To factorize a cubic polynomial completely, follow these steps. Step 1. Use the factor theorem to find one linear factor, open bracket x, minus a close bracket. Tip, test values of a that are factors of the constant term. For example, if the constant is 6, test plus or minus 1, plus or minus 2, plus or minus 3, and so on. Step 2. Use division, either long or synthetic, to divide P of x by open bracket x minus a close bracket to get a quadratic quotient. Step 3. Factorize the quadratic using standard methods you already know. Let us look at example 5. Factorize P of x equals x cubed minus 6x squared plus 11x minus 6. Step 1. Find one factor using factor theorem. The constant term is 6. Let us test x equals 1. P of 1 equals 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. 1 minus 6 is negative 5. Negative 5 plus 11 is 6. 6 minus 6 is 0. So P of 1 equals 0. This means open bracket x minus 1 close bracket is a factor. Step 2. Divide P of x by open bracket x minus 1 close bracket. We will use synthetic division with a equals 1. The coefficients are 1, negative 6, 11, negative 6. Bring down the 1. Multiply 1 by 1 is 1. Add to negative 6. Negative 6 plus 1 is negative 5. Multiply negative 5 by 1 is negative 5. Add to 11. 11 minus 5 is 6. Multiply 6 by 1 is 6. Add to negative 6. Negative 6 plus 6 is 0. The remainder is 0, which confirms it is a factor. The quotient coefficients are 1, negative 5, 6. This corresponds to x squared minus 5x plus 6. Step 3. Factorize the quadratic quotient. We need to factorize x squared minus 5x plus 6. We need two numbers that multiply to 6 and add to negative 5. Those numbers are negative 2 and negative 3. So it becomes open bracket x minus 2 close bracket times open bracket x minus 3 close bracket. Step 4. Write all factors together. P of x equals open bracket x minus 1 close bracket times open bracket x minus 2 close brackets times open bracket x minus 3 close bracket. The answer is open bracket x minus 1 close bracket open bracket x minus 2 close bracket open bracket x minus 3 close bracket. This is the complete factorization. Now let us move to section 7, solving polynomial equations. To solve p of x equals 0, we factorize p of x and set each factor to 0. Let us look at example 6. Solve 2x cubed plus x squared minus 13x plus 6 equals 0. Step 1. Find one root using factor theorem. Test factors of the constant term 6. These are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Also consider factors of the leading coefficient 2, like plus or minus 1/2. Let us try x equals 2. P of 2 equals 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. Dot 6. 2 cubed is 8. 2 times 8 is 16. 2 squared is 4. 13 times 2 is 26. So we have 16 plus 4 minus 26 plus 6. 16 plus 4 is 20. 20 minus 26 is negative 6. Negative 6 plus 6 is 0. So P of 2 equals 0. This means open bracket x minus 2 close bracket is a factor. Step 2. Divide by open bracket x minus 2 close bracket to get the quadratic using synthetic division with a equals 2. Coefficients are 2, 1, negative 13, 6. Bring down the 2. Multiply 2 by 2 is 4. Add to 1. 1 plus 4 is 5. Multiply 5 by 2 is 10. Add to negative 13. Negative 13 plus 10 is negative 3. Multiply negative 3 by 2 is negative 6. Add to 6. 6 minus 6 is 0. The quotient is 2x squared plus 5x minus 3. Step 3. Solve the quadratic equation 2x squared plus 5x minus 3 equals 0. We need to factorize this. Multiply a and c. 2 times negative 3 is negative 6. Find factors of negative 6 that add to 5. Those are 6 and negative 1. Rewrite the middle term. 2x squared plus 6x minus 3 equals 0. Group 2x times open bracket x plus 3 close bracket minus 1 times open bracket x plus 3 close bracket equals 0. Factor out open bracket x plus 3 close bracket. Open bracket x plus 3 close bracket times open bracket 2x minus 1 close bracket equals 0. Roots x equals negative 3 or 2x equals 1, so x equals 1/2. Step 4. List all solutions. From step 1, we found x equals 2. From step 3, we found x equals 1/2 and x equals negative 3. The answer is x equals 2, 1/2, and negative 3. Always list all 3 roots for a cubic equation. Now, I want to warn you about common mistakes students make. Section 8. Mistake number 1. Missing terms. Forgetting to insert 0 for missing powers during division. For example, x cubed plus 1 becomes coefficients 1, 0, 0, 1. Do not forget the zeros. Mistake number 2. Sign errors in factor theorem. For x plus 2, using a equals 2 instead of a equals negative 2. Remember to change the sign. Mistake number 3. Confusing remainder and factor. Thinking a remainder of 5 means open bracket x minus 5 close bracket is a factor. The remainder must be 0 for it to be a factor. Mistake number 4. Stopping early. Finding one factor but forgetting to solve the remaining quadratic part. You must find all roots. Mistake number 5. Synthetic division limits. Trying to use synthetic division for divisors like x squared minus 1. Only use it for linear x minus k. Now it is time for class evaluation. Section 9, I want you to pause the video and solve these in your notebook. Question 1, use long division to divide x cubed plus 2x squared minus 5x minus 6 by x plus 1. Question 2, Find the remainder when 2x cubed minus 3x plus 1 is divided by x minus 2 using the remainder theorem. Question 3. Show that x minus 3 is a factor of x cubed minus 2, x squared minus 5x plus 6. Question 4. Factorize completely. X cubed minus 3, x squared minus 4x plus 12. Question 5. Solve the equation. X cubed minus 7x plus 6 equals 0. Take your time. Write down your steps. Do not rush. I will wait for you for your assignment, section 10. Please do these at home. Question 1. When p of x equals x cubed plus x squared plus bx plus 6 is divided by x minus 1, the remainder is 12. When divided by x plus 2, the remainder is 0. Find the values of NV. Question 2. Factorize completely. 2x cubed minus 5x squared minus 4x plus 3. Question 3. Solve the equation. 3x cubed minus 10x squared plus 9x minus 2 equals 0. Question 4. Given that x plus 1 is a factor of x cubed plus kx squared minus 4x minus 4, find the value of k and the other factors. Question 5 is a challenge. Solve x to the power of 4 minus 5x squared plus 4 equals 0. Hint, let u equals x squared. Let us do a summary of what we learned today. Section 11. Division follows the formula p of x equals d of x times q of x plus r of x. Use long division or synthetic division. The remainder theorem says the remainder when dividing by x minus a is p of a. The factor theorem says x minus a is a factor if and only if p of a equals 0. To factorize cubics, find one root using factor Corin's theorem. Divide to get a quadratic. Then factorize the quadratic. To solve equations, set each factor to 0 to find all roots. And remember, always use 0 placeholders for missing powers during division. I know this was a long lesson, but you have done amazingly well. Polynomials can be confusing because of the many steps, but you now have the tools to handle them. Remember, practice is the key. The more you practice division and using the theorems, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching, keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.